Hello, everyone.
Hello.
Welcome to today's Legacy Modernization webinar. Can everyone hear me? If you have any issues, just send us a chat message. Okay, perfect. So everything seems to be working perfectly, so we'll immediately dive into today's webinar on legacy modernization and how to speed up your modernization project and limit the risks of data migration. So first and foremost, let's give you a brief introduction on Rever and what we do. Rever is a spin-off of the University of Namur, and we are specialized in helping you to map and master all of your data by using automated and industrialized reverse engineering technology. We as well have tooling and solutions to automate and industrialize modernization and migration, to do some data protection in the form of anonymization and pseudo-anonymization, but as well with our data semantic suites that we presented in our previous webinar, we do some regulatory compliance. And then last but not least, we have the world's most used, with the editor of most world's used data modeling technology, which is called DBName. As I said, we are an innovative software publisher. We are a spin-off of the Database Engineering Lab of the University of Namur in Belgium, and we have been around since 2004. We have been operating across several industries, going from finance and insurance to public service to aerospace, automotive, and so on. So all technologies are widely used both in large organizations, but as well in medium-sized organizations. So let's dive in today's subject, which is how to automatically and in an industrialized way migrate legacy data and modernize legacy systems. So before we really go into all the details, I would like to give you a brief overview of why this is important and why actually most of data migration projects fail. That's not something that we say that is that has been widely researched by Gartner and other analysts, and every analyst and university actually is coming up with failure figures of data migration projects of between 79 to 86%. So why do projects fail? And the main 7 reasons are the following. First of all, the systems are poorly understood and undocumented. Now, every company's data landscape is unique, and many organizations have decades-old mainframes, but as well homegrown one-off databases that have not been documented at the time, and where perhaps key staff is nearing retirement or already left the organizations for others. The second reason why a legacy modernization project fails is actually because the requirements are incorrect or incomplete and don't reflect the reality. Data migration projects typically, data migration requirements developed based on assumptions rather than actual fact are often the most common issue. So it is extremely important to be able to actually build a cartography, understand the existing environment before you start planning the future environment based on your business requirements and technology requirements. The third reason why data migration projects fail is for poor data quality and incomplete data. Your new system is only as good as the data underpinning it, and often there is missing, invalid or inconsistent legacy data that can cause adverse effects on the new system. So it's again extremely important to be able to really understand very well what you have in your legacy systems, as well the quality of these, and to have this data quality drive in parallel running with your migration project. And then, of course, the lack of attention to detail. In many applications, there are fields with the same name that mean different things, and that can be both within and across different systems, the same or different systems. A different field name may be used for the same purpose across systems, or multiple values may have the same underlying meaning. That's something we see very often in client engagements. And of course, you have many issues around formatting, for example, date and time formatting, field length differences, and so on, that can be overlooked, and that can have a disastrous effect on the new system. And as well, as long as you, when you start your migration project, what we see is that there are constant changes. The data migrations are all about change, but even the most thought through business requirements starts to change once your testing gets underway. And that's a point where we saw many failures in the past, and our technology can help you to mitigate these risks. And then a general remark from Gartner and the other analysts is that the lack of planning and testing is often a huge issue, and a huge point that is very underestimated with data migration. And last but not least, poor communication. Data migration is generally part of a larger project, and that means that you must coordinate teams and many changes to complex technical requirements. And you also have at the same time to engage with the business functionality. And without a strong IT and cross-functional team communication, you often see that unintended results are bound to occur. And this is as well something that our technology and our methodology can help you mitigate by standardizing and communicating very clearly to everyone on what we are or how we are going to tackle those issues. So let's have a look at, before we dive into all the details of the different parts, on what our technology does. So first and foremost, the aim of a legacy modernization is to migrate your legacy data environment to a new or digital environment. Why do you do that? First and foremost, our clients do that because they want to offer new digital services to their clients, and their existing database and data environments are not able to cope with those new business demands. But as well, many of our clients actually want to migrate because of the costs involved. It's widely known that legacy database technologies are much more expensive and less flexible actually than the new SQL relational environments that are available, or even other new technologies. So what will our technology do? Our technology will start by actually looking at your complete legacy environment, and it will build a complete data cartography. At the same time, we will provide you the tools that will enable you to model and design your new database environments. And those two pictures or cartographies will be fit into a robot generator, and the robot will then be created or built automatically by the technology, and it will start first and foremost creating your new digital environment, build that digital environment, and then migrate the application. Every time something changes in your new environment or in your legacy environment, the structure of your databases changes or the application changes, the robot will be generated again and adapted automatically, so it will still continue to work. But more importantly, once you start using your new data, you can actually start using automatically your old application and pass through the robot and start using your new digital environment. So your legacy applications will not drastically change, the logic will remain the same, but all robots will actually ensure the communication remains and your applications remain working as if they were working on the old legacy databases. Meaning that you have an immediate return on investment because you can stop the costly licensing of the databases, but as well the costly maintenance. Then after that, once you dissociated your data from your application, you can start migrating your apps. You can rewrite your apps, you can change your apps, and these apps can start connecting directly to your new digital environment without the need of going through the robots. Again, every time something changes, our technology will rewrite and regenerate the robot and adapt it so the legacy environment, what remains in the legacy environment, will still continue to function, but as well, your new applications will be able to function with the new digital environment. That was, in a nutshell, how our technology works. So our technology is an automated and industrialized technology that will allow you to migrate your database environment and as such dissociate your data from your legacy applications, which will allow you to avoid having to do a big bang approach of migrating and your data and all your applications in one go, but you will be able to migrate your data, remove most of that complexity, and then start migrating the logical parts of every application to your new environment. But you will as well be able to immediately start building new applications that offer new digital client services that will connect automatically to your new database environment. So what is legacy environment, legacy modernization? As I said, while we dive into the details here, the goal of a legacy modernization is actually to migrate from a source data, a legacy database, towards a new relational database or digital technology database. In the source database, you have a connection, or the programs, the applications are connected to the source database. In the new environment, after the conversion, you will have the programs with the wrappers, and the wrappers is what we commonly as well call robots. So you will have only a small change in your technical environments initially. So the first step is that we will do some database re-engineering or reverse engineering on your existing legacy environment to redocument that environment to understand all the structure of the databases. And then we will as well do the re-engineering of the new database, so design the new database and start migrating. So as I said, the goal is to migrate the source database, do some database re-engineering to deriving the target database from the source one. So everything we do is linked to each other. It's not about throwing away the past and replacing it with the new. It's about building on what you have, keeping the good parts, and actually opening the opportunity to these places. When you look at the entire migration methodology, the first part is the reverse engineering, understanding the past, what you have, the link between your data and your applications, the link between data, and so on, and the way data is actually changed and handled within your legacy environment. We will then look at your model transformation, which is really about looking on how do we link the source database, the structure of the source database to the target database, which you design, by the way, in our modernization technology. So you will do the reverse engineering. We will then model the transformation and design the target database. And then our technology will create the target database and migrate the data from the source to the target, as well as validate and test that data. And then it's up to you to start doing the program's adaptations, but as well rewrite the applications if that's something that you have to do in your project. So the first step is reverse engineering. So there, our technology will automatically retrieve all the metadata using DDL analysis or JDBC. It will as well look at the physical models of the database. And then in the next step, we will refine that model. So the objective of that is to recover the programmer's view of the database. So we will look at the detailed definition of the records, the redefines, the arrays, the types, and so on. And we will analyze as well all the copybooks, the subschema, and the source model of the database. So as you can see here, we do the metadata extraction, the program refinement. All of that is stored in our Rever repository in our tools, and then the user can maintain, enrich, visualize, query, and explore actually his data. Here's an example of how we extract COBOL, and we actually move it to a new database model. And once we've done that reverse engineering, we look at the model transformation. And that's a really crucial part because it's all about keeping the link between your old model, your old legacy environment, and the new. So keeping the good structure and of the old environment and then migrating. So the first part is to transform the source structure to the target equivalent, because some legacy structures are not accepted in SQL database. So that means that there are typically some choices to be made. And our technology and our team can help you to decide on how to handle these. And then you will as well have to transform the types. So legacy database have only few data types, but modern databases have a lot more. And it's important to choose the right type. Again, this is something that you can do with our technology, and that our technology will help you with, and as well if you are stuck, and our team of data scientists and experts can help you with that as well. Then the fourth step in model transformation is to look at the name transformations. Legacy and SQL database have different naming rules, and it is important actually to harmonize and to make a decision. So it can be useful to give more meaningful names to comply with the actual naming convention within your organization. It will as well make your database more understandable and readable, maybe for less technical persons, allowing you to as well use maybe less skilled or more junior resources in your data environment. And last but not least, we have as well the physical design of the database, of the new database that is being performed. So again, the model transformation is the second step, and here you can see it in a more graphical way. Here's some examples again of model transformation, and as you can see, it's our tool dbmain, which is available to download on our website that you can use for that, and that will help you to build that new model. The third step in our migration methodology is migrate the database. So the first thing we will do is create a new database, and we will our technology will generate the creation of the DDL based on the target model that you designed in our tool, in our modernization tool, and then it will execute the DDL. So you will end up with your new database as it was designed by you, and then you will start migrating. And what the tool will do, as you could see beforehand, it will actually look at both models from your target database and your source database, and automatically generate a migration, so dynamically, automatically generate a migration programs. It will compile and execute those programs, and then, of course, once the data is migration, it will validate the data migration. And this automation, industrialized and intelligent automation, is really what differentiates us from any competition out there. And it is as well this methodology that allows you to mitigate the risk and as well speed up many of your migration projects. So here again, it's a graphical representation. You can see the Rever repository that you saw in the previous step. That will actually generate the migration program. At the same time, our technology will use the DDL generator to create the target database, and then we will migrate from the source database to the data migration, using the data migration programs. These data migration programs, and as well all the robots, can after that be generated, dynamically generated over and over again if something changes within your environment. And the fourth step, which is of course really important as well, is the program's adaptation. So first of all, our data wrapper, which is the robot, will simulate the legacy management system on top of the target database platform. So that means that your old applications will be able to work with the new environment, and as if nothing's changed. So the wrapper in itself will actually do the conversion of the structure, but as well automatically and dynamically do the conversion of the language. So that means, again, that communication between your old legacy applications and the new data environment will keep working, and your applications can still continue to work as if they were using the old data, but in fact they are using the new environment. The technology, as I said, will generate the wrappers and the wrappers or robots based on the both models, on the new models and the old model, and then the program transformation will take place. The program modifications in our methodology are kept to a minimum, which is really important because the logic of the program does not change. And this means that you will actually, the developers and the persons that understand the application will not get lost in the new environment or in the applications. So you can keep on, you can keep the lights on while you are building and rewriting the programs after that and developing those new digital services. So as you can see, once you migrate the database was created and you migrated the data, or a robot generator will generate a robot or wrapper, and that wrapper will ensure the communication between your legacy technology and your target database and vice versa. So what are the advantages of our methodology? Is that first and foremost you have a reliable risk management. You will, why is that? Because you dissociate your applications from your data. So you are not forced, first of all, to, first and foremost, to migrate and your application and your complex data environment in one go. You dissociate your data and your applications. And our technology will allow you then to, using our reverse engineering, to identify all the technical project risks at the beginning of the project. So that will allow you actually to do the planning, to better communicate to the business, and as well to better automate the whole migration process. The data migration validation process is independent of the application in our technology. And this means that you have a real exhaustiveness of the validation process, but as well consistency in the way this is handled. And then, of course, there's an intelligent automation, because what we do is not write a connector. It's actually our technology will generate the robots, the wrappers required to be able to using the different models, data models that you have, and to be able to generate the database and migrate it. Because you migrate your databases first, you will actually lower your costs and have a very fast return on investments. Because we know that databases and legacy databases are extremely expensive to maintain, extremely expensive in licensing costs, and an equivalent technology or even a more modern technology in a modern environment, in a digital environment, will be much cheaper, and that means that from the start of your project, as soon as you start migrating your data, you have an immediate return on investment, which allows you to reuse that return on investment to redevelop your applications and actually go to the next steps. Using our technology and as well our process, our migration and standard migration process, you will actually simplify and accelerate the whole process. And as well, you will future-proof your return on investment by removing constraints from database evolutions. The data remains available to all users, and new programs can directly access the new data as well. So if you look a bit further at the more technical advantages, then you will see that the native target database is independent from the source database. There's no technical column specific to the source database. New programs can easily access the target database, and you can as well use the program, so the old programs work with the new technology, and that's what brings is immediate return on the investments. The program logic doesn't change at all, and the simulation of the legacy database system, DBMS, is there's a simulation of the legacy data management system on top of that database. And then, of course, the risk mitigation, which is extremely important, seeing that many of data migration projects fails, is that data migration is actually performed before the program are transformed or migrated or rewritten. There's a very strong automation by code generation by using the models, and there's an automatic check and validation of that conversion. So you will have an immediate impact on data quality, on the speed of your migration, and so on. So we've done some very complex migrations at Eurocopter, at PME, at Pôle Emploi, at Securex, at the Ministry of Finance in Belgium and Luxembourg. We've worked in the US and across the US and across Europe, and we have many references. So now I open the floor to any questions that you may have. Okay, so we have a question from Carl, which is how long does a typical migration take to complete? So next to me I have Jean Henrat, which is our technical lead for all of our migration projects, and he'll be happily answering that question.
Well, like usually, it depends a lot of the project. Big part of the time used in the migration is the understanding the legacy application to retrieve all the cartography of the legacy database. When this is done and we understand, well, it goes quite fast. It depends also the technology. We have experience with several technology, and we have developed robots for several technology. If we use the robots already existing, we can do it in few months, a middle-sized project.
Yeah. So typically what we see, when we compare, we have many clients that try to use, the more traditional ways of doing a migration project, and as the analysts show, there's a high failure level. Typically, after the failure, they start analyzing the market to see who can help them to actually automate or de-risk the migration, and maybe start to migrate in a more sensible way. And typically, we see that projects that beforehand, where clients spend up to 2 to 3 years trying to migrate an application, and then decided to pull the plug, that we can do them on average between 3 and 6 months time. So you really have a time saving of around 80%. Of course, we are specialists in data and automating and validating and industrializing data migrations. And we are specialists in cartography and helping you to understand and redocument your existing applications and legacy applications. But then there's still the migration of your applications, and by actually dissociating your data from your applications, you can often as well migrate your applications with in-house teams. And you can do that gradually and really removing those risks. Does that answer your question, Carl? Thank you. So if there's any further questions, we can if you have, sorry, if you want any further details on that, we can link you up with the team, and you can have an offline discussions about the details of that. Are there any further questions? So, do we support hybrid on-premise and cloud scenarios? The answer is yes, but it is actually, it really depends on the technologies out there, and this is our technology is a very powerful reverse engineering technology. That's why the company is called Rever. And our technology can go and really identify most of the data and the data lineage and so on within your organization. This includes as well, of course, applications and data that are stored in the cloud and in hybrid on-premise situations, but it really depends as well on how far we can go. It really depends on the access rights that you have, and as well the security policies of your organization. So when we have when we see that, or where do we see the most problems is typically where you are in a shared environment where it's more difficult actually for your cloud provider to give you access, because there might be an impact on other clients. But typically, yes, our technology can start cartography and understand your up to 100% of your technical environment. And once we have that cartography, we can feed that into our robot generators, which will allow you to migrate. But again, it's a great question, and we can certainly take that offline and evaluate with you whether it's feasible for the specific environment you're thinking of. Okay, so in that case, if there are no more questions, it only remains us to thank you for joining us for this webinar. This is a second webinar in a series of other webinars. So you will probably be invited or get invitations for the next webinars. A recording of this webinar will also be made available. And if you have any need or want to see your technology work to see how it works in real life, it's something that we will be happily to organize for you. So thank you very much. Have a wonderful rest of the day, and talk to you soon.